This is the second video of week 11. We're still going over chapter 8, confidence interval. After this lesson, we're gonna go ahead and complete a short Canvas quiz together for week 11 attendance grade. I took attendance by week 10 attendance was you completing your exam too. Week 9 attendance was you guys completing your practice test. We spent about 2 weeks on that, preparing for that and taking that exam, but that got us about like a week behind. But I think that was necessary as we are all of a sudden going remote. We only have one exam left, right? And we call that one the final exam. But final exam only covers materials that we started this week, chapter 9, 10, 8, 9, 10, and a little bit of chapter 3. So it's not going to be cumulative. So for the next 3 weeks, we're going to go over the inferential statistics. And in this lesson, we'll construct confidence interval to estimate a population proportion. We'll be done with confidence interval this week, and we'll do hypothesis testing next week. It's kind of busy, but we're also going to use StatCrunch to save some time in terms of calculation. So we'll make it through. Got about 35 slides here. This may be a little bit longer than the first one, 8.1, when we were just kind of talking about introductory stuff. But now let's actually construct a confidence interval to estimate a population proportion in this lesson. And you do have the notes that goes with it. It's been posted here. And what you will notice is that we're doing the first 4 pages together and the interpretation part on page 5, but the understanding check. I made these 6 questions into a Canvas quiz. We'll take that quiz together because I want everybody to just get 100 for the attendance grade there. All right, let's open up the slide for 8.2, constructing a confidence interval to estimate population proportion this time. 8.3, we're going to do the same thing, but to estimate the population mean. But here, our goal is to predict what P is. Population proportion, remember we use the little P for the symbol. So here are the steps for finding the blank blank percent confidence interval. 90%, 95%, 99%. Common one is 95%. But any any confidence interval, any level, we can use the same steps. We're just going to have a different z-score that we're using. Now listen, step number 1 is finding the z-score that corresponds with the confidence level given. So the z-star, or the critical value, is the number just found from the standard normal table or the StatCrunch normal calculator. That's what we did in 8.1 lesson. The 4 examples that we went over at the end of 8.1, we were just finding these z-score values, right? These are called critical values that we're going to use to create a confidence interval in this section. Now, because we found them together, let me just review those with you. For 90% confidence interval, this is what we did. We found, having 90% right in the middle means we have 10% to the left and right of it together, right? That means since the normal distribution is perfectly symmetrical, 10% to the left and right means we have 5% to the left of it. This is the 5th percentile, okay? So the 5th percentile was negative 1.46, but the z-score that we're going to use is 1.46 for 90% confidence. 95% confidence, remember, by the empirical rule, it was 2 standard deviation above and below the mean. That's where we had that 95% of data, and that 2 was rounded up, but in a little more accurate way, z is 1.96. Do want you to memorize that one or know that one for sure. 95% confidence interval, that's the most common one that we're going to work with. 1.96 is the critical value that we will use, okay? Maybe sometimes you also find 99% confidence interval, and for that z-score, we have to just make it a little bit wider. The z-score is 2.58. 2.58 to the right side, 2.58 to the negative 2.58 to the left side. So these are the 3 big critical values that you will use for population proportion of the confidence interval for population proportions. So I want you to have them in your notes. Now step number 2. Find the sample proportion p hat. This is what we're going to call point estimate. Remember, we talked about there are 2 ways to estimate the population parameter. First one was that best guess, the single number best guess, and that was called point estimate. Our point estimate is for the population proportion is going to be sample proportion. Okay, and p hat, that's the symbol that we use. We symbolize a population proportion by a regular little p, but we're going to put a little triangular hat on top of that p for sample proportion, and we read that as p hat. Okay, on the point estimate of the population proportion is the sample proportion. So that number that we're going to add the margin of error or subtract the margin of error, the midpoint is going to be the sample proportion. So you need to find that number, okay? P hat, that's going to be the sample proportion, okay? All right, number 3. Now let's find the standard deviation. And when I show you the standard deviation formula, you'll be like, oh, I've seen that before in chapter 7. Yes, you did. Here you go. But here's the thing though, it's a little different, right? The one formula that you use for standard deviation of sampling distribution of sample proportion in chapter 7 was the one with the regular p. Notice we put a little hat over them. You know why? Because we don't know the population proportion when we are trying to create a confidence interval to capture it. We do know the second best thing though. We do know our best guess at this population proportion is something called sample proportion. And the symbol that we use for sample proportion is p hat, okay? So it's the same formula that we used in chapter 7.2, but we're just going to put a hat over our p's, okay? So the standard error is going to be this formula. We'll use that together in our first example, first and the second example. All right, step number 4. Write down somewhere on your paper that the margin of error equals Z-score times standard error. I think it's going to show you somewhere else, but what we mean by the margin of error is how far we're going to go up from our point estimate or how far are we going to go down from that point estimate, but that's just that number that we're going to add or subtract to the point estimate. But how do we find that margin of error? It's by multiplying the z-score that we found in step 1 by the standard deviation that we just found in step number 3. We're going to multiply those two, okay? Multiplication is not difficult, we just multiply them, but you gotta know that the margin of error is really the product of the z-score that we found in step 1 times the standard deviation we just found using that the p-hat formula. All right, so here we go. Here's the confidence interval. Guys, confidence interval has lower limit and the upper limit. It looks a lot, but this is what we really are doing. The point estimate, that sample proportion p hat is your midpoint. That's the middle of the interval, okay? To go up to the upper interval, what you're going to do is you're going to add the margin of error. To go down to the lower limit, you're going to subtract the margin of error. And like we said, the margin of error is simply the product of z-score times the standard error, okay? So here's the formula for blank % confidence interval. And whatever that confidence level is, depending on is it 95, 99, or 90%, the z-score will change, okay? But the lower limit is going to be p hat minus z-score times standard error. I'm just going to go ahead and writing SE for standard error from now on, okay? And the upper limit is going to be p hat plus exactly the same margin of error, z-score times SE, the standard error. That is how you find confidence interval. Let's put some numbers to it so that we can use these 4 steps to find it. But hold on a second. We find this confidence interval, we should be able to interpret this. So step number 5, we're going to be drawing a conclusion from your result from the numbers that we get on these confidence intervals, okay? So we'll do that by filling the blanks. I wrote down a couple sentences that we can just fill in the blanks to draw the conclusions. But here's our first example. Ready? I forgot what GSS stand for, like what social service survey, something like that. But I think we read about it in 8.1. But in 2010, the GSS asked subjects if they would be willing to pay much higher prices to protect the environment. What's your answer? Are you willing to pay much higher prices to protect the environment? My answer is yes. I'll be willing to pay a little more. But let's see. Of n equals 1361 respondents, so they went around and asked 1,361 people, right? Oh, 637 were willing to do so. Here's what I wonder. What's the percentage? So on my little scientific, oh, not even a scientific calculator, on my little cell phone calculator, guys, this is what I'm typing. I am doing 637 divided by 1361, and I got 46.8%, 0.468. So what I got is only about 46.8% of these, people who got surveyed were willing to pay much higher prices to protect the environment. Now that number is less than 50%, so I would say the majority are against this. But anyways, what they want you to do with this information is find and interpret a 95% confidence interval for the population proportion of adult Americans willing to do so at the time of the survey. Now, what we are assuming is that this sample better be good. This sample is random. This sample is going to be a good representation of American adults, because we're about to use the sample statistics to draw a conclusion about population parameter. We're doing statistical inference now, right? So let's create this. Remember the confidence interval level? 95% confidence, okay? Ready? So step number 1. Because we said we want 95% confidence, right? So find the z-score that corresponds with our given confidence interval. If you want 95% confidence interval, you remember that the z-score is 1.96. If you don't know how to find it, please review 8.1 lesson. We just read that z-score from the normal standard normal table or the StatCrunch calculator. Okay? Alrighty. Now what's step number 2? All right, let's find that p-hat. Let's find our best estimate for the population proportion. Let's find the sample proportion, okay? Sample proportion, what was the symbol we used? P-hat, okay? So what's that p-hat? Remember, only 637 were willing to do so out of 1,361 people who got surveyed, right? So p-hat is going to be 637 divided by 1361. So p-hat, the proportion in the sample, is 0.468. Guys, what I noticed is after I was done making these slides, that number is right. 0.468 is right, but I think I started typing 0.467. But I'm just gonna be what? 0.001 away from the. It's gonna be okay. Okay. But let's go on. But that you have to find the sample proportion first, called p-hat. Alrighty, now let's find the standard deviation using that formula, the p-hat formula. It's called standard error, but that one we're gonna have to use the p-hat that we just found. So here it is. Oh, thank goodness, I used the number 0.468. Do 0.468 times 1 minus 0.468 and divide that by 1361, that's the sample size, right? And take square root of that number. If you do that, you will get the standard error of 0.0135. And if you're wondering about how I'm rounding, I'm just rounding however I want. I don't want to round it to like 100. So I have 4 decimal places just to be accurate. But usually you really don't want to round too much in the middle of a problem, and we're only at step 3, so don't round it way too much, okay? Step 4, ta-da, well, we're just finding this confidence interval right here. It looks a lot, right? I'm sorry, it looks really bad with the symbols and everything, but let me tell you what, the only operations that are involved right here is multiplication and subtracting and adding. That's all. This is what you're going to do. P-hat. P-hat is your middle point. P-hat is the number that you're going to start from, but you will go up a little bit to find the upper limit. The upper limit came out to be 0.49, and you will go down a little bit from that point estimate, and you will go down to 0.44. So the work that I have, well, I wrote it as a 3-step. I'm just finding the confidence interval using all those little numbers that we found. Remember, p hat is 0.468. Like I told you, I should have typed 0.468, but I accidentally typed in 0.467. But thank goodness, because of rounding, it didn't really make it, but I want you to please write down 0.468 on your paper, okay? Because the p hat is really 0.468. But look at what I'm subtracting from that point estimate. 1.96 is the Z-score, right? Z-score for 95% confidence interval. And I'm multiplying that by 0.0135. And guess where that came from? That is the standard error. So you multiply first, and then you subtract that from the point estimate. And you add that same number to that point estimate to get up to the upper bound. That's what they are doing. So it just looks bad because the numbers are just trying to be accurate. But all you have is the middle number. We're adding the margin of error to get to the upper limit. We're subtracting the margin of error to get to the lower limit. And this is the confidence interval. This is the 95% confidence interval that we can create by doing everything by hand, really, right? But you may wonder, a good question, like, can we do this on StatCrunch? And the answer is yes. Yes, you can. But I needed to show you how we're using the Z-score standard error to create the margin of error, to add and subtract from the point estimate to create these upper limit and the lower limit to make the confidence interval. But we can ask StatCrunch to do all that for us. So watch carefully, okay? This is where you're going to go. Go to stats, please. Go to proportion stats. Why? Because we're trying to create a confidence interval to estimate the population proportion. So go to proportion stats and click on one sample. We only had one sample of size 1361. It's not two sample. We'll look at two sample cases later in a different chapter. I'll click on with summary because we were given the summary of this. Like, they may give you data on a MyLabs homework, and I'm planning on going over some homework problems after 8.3 lesson video. So we'll do that. And I'll also like it very much if you can email me which specific homework problem you want to go over together. That will be really great too. But I hope you are there, and this is your input. Number of successes refer to how many people who said they're willing to pay higher prices to protect the environment. 637 people said yes. So that's the number of successes, and number of observation refers to the total number of respondents. 1361 is the sample size, so type that in. In chapter 10, we will use this hypothesis test for P, but not yet. We're in chapter 9. We're trying to find the confidence interval for P. So click on that. And I think the default level, guys, is 0.95, 95%. So I don't think I changed it. So keep the level as 0.95 for 95% confidence interval. But as you know, we're going to have to change that number if you want something other than 95%. Just keep the same method standard and then click on compute. Guess what they're going to give you? Ta-da! This is what they're going to give you. Let's look at this table together. This is a 95% confidence interval for population proportion P, where the count was 637 out of total of 1361. Sample proportion, that's their p hat. They didn't really use a symbol p hat here, but this is the p hat that we got too, 0.468, right? I accidentally have 0.467 somewhere on my slide, but that's okay. Let's just close it up, I say. All right, the standard error is the standard deviation that you found using that p hat under square root formula, right? And they didn't really give it to you, but what was that critical Z-score that we used? 1.96, right? You multiply that 1.96 by standard error to get the margin of error. This table didn't give you the margin of error, but the margin of error can be found because what you can do is upper limit minus the sample proportion is going to be the distance that you have to go up from the sample proportion to get to the upper limit. So we're going to talk about how to look at a confidence interval and go back and find the point estimate or the margin of error on that one Canvas quiz, and they're just all related, right? Sample proportion is right in the middle of lower limit and the upper limit, and the margin of error is how much you went up or down from that midpoint to get to the lower or the upper limit. Okay, so all right, the number that we got on StatCrunch is exactly same as what we got. I mean, I have to round it a little bit, as what we got by doing it by hand. So you have an option. If you have a homework problem that's asking you to find the confidence interval, just know that you know how to do this by hand, but you may definitely use technology to do this. We should do at least one more example, but before we go to example 2, let's interpret this result for step number 5. What does this tell us about the population? Based on the surveyable, we can conclude that at the 95% confidence level, we estimate that the population proportion of adult Americans willing to pay much higher prices to protect the environment was at least 0.44, but no more than 0.49. 0.44 was the lower limit, 0.49 was the upper limit, so we get to say that. But in an easier way, I mean, we can convert this into percent. That is between 44% and 49%. And we are 95% confident that the true population proportion will be captured in that interval. So you know what makes me sad is that this interval is completely below 50%. So the majority doesn't agree on paying extra. I mean, the wording of it has a problem, don't you think? Much higher prices. I mean, if I hear that wording, I'll be like, probably not. Okay, but the other two blanks, the point estimate of 0.47 has a margin of error of 0.026. I mean, I rounded it a little bit, sorry, but that point estimate is the p hat, and what we had to add to that p hat to go up to the lower limit, to up to the upper limit, and go down to the lower limit is called the margin of error. Let's do another example. Come on. All right, example number 2. And I think this one asks you to do a much higher confidence level. Guys, I think I got common cold. I'm so stuffy right now. But I don't want to stop this lesson in the middle of it. So let me see. I've been going for about 22 minutes. I think I'm about halfway there. All right, let's keep going. But you know, I'm kind of glad because remember our face-to-face class was usually how many? 3 hours long, right? At least now I get to kind of divide up the lesson and post it throughout the week. Or I try to definitely post everything by Sunday so that you guys can have the whole entire Monday through Thursday to get the lesson and try the homework. But, oh, sometimes, oh, it's my husband sending me, what's that? That's the pregnant emoji. Yeah, that's me. Sorry. I don't know how to turn off these messaging on my phone. I'm gonna go ahead and click as marked as red. All right, example 2. To test the effectiveness of a new method of vaccine. Oh my goodness, he needs to stop. Guys, I am so sorry. I'm gonna tell him to stop right now. Somehow, when I got my new iPhone, I said stop. Chicken. Alright, I'm back. I apologize. I don't know, my cell phone, when I get messages on my cell phone, it pops up on my iPad, on my iPod, and my Apple, MacBook. She's showing up everywhere. When I get a phone call, like 5 devices in my house rings like crazy. It's crazy. I don't know how to turn this off. Alright, anyways, example 2. Let's find another confidence interval. To test the effectiveness of a new method of vaccine, which allow growing viruses in cell cultures in a recent clinical trial, N equals 3,900 randomly selected healthy subjects aged 18 through 49 received a cell-derived influenza vaccine by injection. It's a big sample size, guys. Remember, sample size is 3,900. During a follow-up period of approximately 28 weeks, each subject was assessed whether he or she developed influenza. Do you want that number to be big or small? I want that to be small, because if the vaccine's working, they shouldn't get the flu. Which happened for what? Only 26 of 3,900 subjects. Yay! That number is so small. That's good for the vaccine making people, but it's going to be kind of ugly for our number because it's going to be a very small proportion. P-hat is going to be tiny. They want you to, oh, look at them. They want us to be very confident in this interval. They want us to create a 99% confidence interval for the population proportion developing the flu over the follow-up period. So assuming this healthy subjects who are randomly selected are going to be a good representation of the population, we're going to go ahead and create this confidence interval for them. Let's do that. Come on. Okay, step number 1. Let's find the Z-score, the critical value that corresponds with our given confidence interval of 99%. That one you can just look it up from our previous notes, right? 99% confidence interval, we should use Z-score up to 0.58. If you want to know how to find that 2.58, please go back to 8.1 lesson, okay? That's how when we talked about how to find these Z numbers. Next. Let's find that point estimate. Let's find that sample proportion. And that number is going to be very small, remember, from what we read. Remember, only 26 of 3,900 subjects developed the influenza. So P-hat is going to be 26 divided by 3,900. And that came out very small, 0.0067. Keep that number. That's the midpoint. That's the number that you're going to add or subtract to get to the upper or lower limit, okay? But that's the midpoint. This is going to be called a point estimate, okay? P-hat. Step number 3, let's find the standard deviation, standard error using the formula, our P-hat and the square root formula. So P-hat, we just found it together, 0.0067. So if you subtract that number from n, multiply those two and divide it by 3,900 and take square root of that, you will get, I know you will, on your calculator, you will get the standard error to be 0.0013. Listen, standard error is not the same thing as the margin of error. For our standard error to become the margin of error, we need to multiply this SE, the standard error, by the Z-score that we found in step number 1. So, if you want to find the confidence interval, this is what we want to do. Start from the point estimate of 0.0067. Multiply the Z-score by the standard error, and either subtract it, go down to the lower limit, or add it to go up to the upper limit. If you do that, and if you just kind of round it to the nearest 10,000th, you will get the lower bound is 0.003 and the upper bound is 0.010. Feel free to stop this video and try this math part by yourself with the tiny small calculator. It will come out exactly the same. All you have to do is multiply the Z-score by the standard error, subtract it from the point estimate, or add it to the point estimate to find the lower and upper limit. All right, well, we can check this using StatCrunch. So where do you go? You go to Stat, Proportion Stat, go to One Sample, and click on With Summary, please. For the number of successes, people who successfully developed influenza, sounds weird, but that was 26 out of 26 out of 3,900 subjects. So number of successes, 26. Number of observations is 3,900. Ignore the hypothesis testing, we're not doing that yet, but click and say that we want the confidence interval for population proportion P, and tell them the level that you want is 0.99. You want 99%. You don't want 95% for this one. All right, click compute. Ta-da! This is what you're going to get. They got the standard error for us. They didn't tell you the margin of error, but you do know how to find it. So maybe on the third exam, for the final exam, I will ask you to find the margin of error just to see if you know that the margin of error is simply the Z-score times the standard error. Lower limit and upper limit matches what we found by hand. Just have to round it a little bit, but that's an option for you to use, and that's available for you, okay? All right, let's interpret this, okay? based on the clinical trial above, we can conclude that at the 99% confidence level, we estimate that the population proportion of developing the flu over the follow-up period was at least 0.003, but no more than 0.010. That is in between 0.3% to 1%. It was less than 1%. So they wanted a pretty accurate, pretty strong confidence level, but our interval, I think, came out very great. The point estimate, the midpoint was 0.0067, and that had a margin of error of 0.0013. Again, margin of error is not the same thing as the standard error. Margin of error is Z-score times the standard error in this case, okay? Okay, so you've seen enough of creating confidence interval both by hand, and by using StatCrunch. Let's go over a couple important notes about this, okay? For the 95% confidence interval for a proportion P to be valid, you should have at least 15 successes and 15 failures. Remember, the vaccine case, out of 3,900, only 26 developed the influenza, but 26 was still greater than or equal to 15, so that one was okay. So in order for you to use this, because we're using normal distribution Z-score, the n times p hat, this p hat this time, the number of successes has to be greater than 15, and then the number of failures, n times 1 minus p hat, also has to be greater than or equal to 15. Okay, if it doesn't, then we can't really use this Z-score. All right, number 2, 95 confidence means that there is a 95% chance that a sample proportion value p hat occurs such that the confidence interval p hat plus or minus 1.96 times standard error contains the unknown value of the population proportion p. 1.96 is from the Z-score of 95% confidence level, right? So they're basically giving you the formula for 95% confidence interval for population proportion. All right, a study that uses higher confidence level, like the vaccine study that we just looked at, they wanted 99%, right? Will be less likely to make an incorrect inference, but will not be able to narrow in as well on where the true parameter value falls. I mean, the example that we had, the interval was from 0.3% to 1%. I wouldn't say that was too wide, but usually, if you go up on a confidence interval, your interval will get wider. And that's not necessarily a good thing, because your confidence interval getting wider means your margin of error is increasing, and nobody wants the margin of errors to get big, right? Remember that little cartoon that I shared with you in 8.1? The one about the weatherman saying, I am like, no, he didn't say I'm 100% confident, but I am pretty sure that's going to happen. The highest temperature tomorrow will be in between negative 40 degrees to 200 degrees. I mean, that's a crazy wide interval. Of course, it's going to capture the true high temperature for tomorrow. But if that is too big, I mean, it's not really telling us like significant, right? So it's not necessarily good to go up on a confidence interval, because if you go up on a confidence interval, then your interval will get wide, and wide interval means you get a big margin of error. This means the higher the confidence level or percentage, the wider the confidence interval, and the lower the confidence level, the narrower the confidence interval. Okay, so 95% confidence interval is not as confident as the 99, but it's narrower. And narrower confidence interval means it's a good thing, because that means the margin of error is small. Okay, so there's a compromise. We must compromise between the desired margin of error and the desired confidence of a correct inference. As one gets better, the other gets worse. You see what I mean? This is why you would probably not use a 99.999% confidence interval. Okay? It would usually have too large a margin of error to tell you about to tell you much about where the parameter falls, its z-score is 4.9. That's a crazy big z-score. Because I can say something like this. I am 100% sure that we will be back on campus for face-to-face classes because Corona will be over. And I can tell you my confidence interval is from tomorrow to 10 years from now. Oh, I mean, like, that's not really telling us anything, right? So, wide confidence interval means, I mean, the confidence level increase, but it's not necessarily going to be good because the margin of error will be way too big. So, in practice, the confidence level 0.95 or 95% confidence is the most common choice, but some applications require greater or less confidence. To increase the chance of a correct inference, we can use a larger confidence level such as 0.99. 0.99 is probably the highest that we will do, but 95 is probably the most common. All right. So here you go. There's a picture of what we were just talking about. Notice how 99% confidence interval, not only that it has a higher confidence level, but it is definitely wider, right? So 95 is a little bit lower, but it's narrower with a smaller margin of error. Okay? Well, I guess the good thing is p hat is still the midpoint of both of the interval. Okay. Let's do two interpretation. A quick interpretation of what this 95% confident means, and let's do the Canvas quiz together. Interpretation of the confidence level. So what does it mean to say that we have 95% confidence? Well, the meaning refers to a long run interpretation, how the method performs when used over and over with many different random samples. Suppose that you create 100 confidence interval, okay? Out of 100 of these confidence interval, about 95 of them will capture the true population proportion. If we used the 95% confidence interval method over time to estimate many population proportions, then in the long run, about 95% of those intervals would give correct results containing the population proportion. I think there's a cool simulation that I may be able to share with you. Go to my I may do a simulation video in another because I think I'm almost done with this lesson and I don't want to make it longer than like 45 minutes because I don't know. Are you still watching? Are you still with me? I think you are. All right, but that's it for this slide, really. We're going to do the understanding check together. We're going to complete this Canvas quiz 8.2 understanding check together for attendance grade so that everybody can get 100. If you don't get 100, I know you're not watching. But let's do this together on Canvas. Please go to Canvas and click on 8.2 Understanding Check. This is how you get attendance credit. And some of you are emailing me about, oh, I was marked absent. Did we have a Zoom meeting? I had an assignment for you to complete and you never completed it. That's why I marked you absent. So hopefully you're with me right now. Let's go ahead and do this together. The larger the sample, the blank accurate the sample mean will be as an estimate of the population mean. The bigger the sample, the better it is in estimating the population mean. So larger the sample, the more accurate the sample mean will be. Because, like, imagine an extreme case. What if your sample is exactly the same as your population? Then it will be perfect match of the population mean, right? So the bigger the sample, the more accurate the sample mean will be. All right, the more variable the data, but this time we're talking about variability. Blank accurate the sample mean will be as an estimate of the population mean. So if you have more variation, the standard deviation is big, the sample mean will be less accurate to estimate the population mean. So the answer for this one will be less. All right, critical value is, okay. Now, critical value is that z-score that we used, and it's also going to be called t-number, t-star, or t-score for sample mean in 8.3. But critical value is, and it's a multiple choice. Let's read which one it is. All right, read the fourth one. It's the fourth one. It's the critical value is the number of standard errors, because remember, we multiply the z-score by the standard error, right? or standard deviation to move from the mean of the sampling distribution to correspond to a specified level of confidence. That is the definition of critical value. So we'll click that. But remember we multiply that value to the standard error, and we use that to move up or down from the mean of the sampling distribution. All right, number 4. Days before a presidential election, an article based on a nationwide random sample of registered voters reported the following statistic. 52%, and they say plus or minus 3% of registered voters will vote for Robert. What is the plus or minus 3% called? So 52% will be the point estimate. That's our best guess. But we're giving them an interval because it may not be 52, but we're about like positive or negative 3 away. Well, it's called margin of error, guys. This is called margin of error. So let's go ahead and create a confidence interval using it. So 52 plus 3 will give you 55% for the upper limit, right? 55 for the upper limit. So, Robert guy may be excited. Yay, I may win this majority vote. But what about the lower limit? 52 minus 3 will get him down to what? 49%. And 49 is less than 50%. And that's less than the majority. So can we go ahead and say that he's going to win? We don't know that because it doesn't even say what confidence interval it is. But part of the confidence interval will go below the 50% because the margin of error was 3% from 52, above and below. Well, by the way, the answer is going to be margin of error here. So we don't know if this Robert guy will win this election. But that number that you add or subtract to the point estimate is called the margin of error. All right, number 5. Researchers study the mean egg length in millimeters for a bird population. After taking a random sample of eggs, they obtained a 95% confidence interval of 45 to 60. Interesting. They just gave us the confidence interval, right? What do they want here? What is the value of the sample mean? Oh, okay. Now, if they ask you for what is the value of the population mean? Well, we're just going to say we're 95% sure that it's in between 45 and 60. But if they ask you for sample mean, we know exactly what it is. Because how did they get that upper limit and lower limit? From using the sample mean, from adding or subtracting the margin of error to the sample mean. What I'm saying is the sample mean is directly in the middle of 45 and 60. It's the midpoint of 45 and 60. Because you added the same number to go up to 60 and you subtracted that same number to go down to 45. So the question is, what's in the middle of 45 and 60? That's what you're going to have to find. So for this one, let me show you a little trick. I'm getting my little calculator out. Do this. Find the middle of 45 and 60. Find the middle of 45 and 60. Finding the average of 45 and 60. Add them together. 45 plus 60, and then divide that number by 2. 52.5 is the middle of these two numbers, okay? So, therefore, the sample mean is 52.5 millimeters. That's how you find the mean, given the lower bound and the upper bound. You add them and divide them by 2. All right, the last one. Graduate student wanted to estimate the average time spent studying among graduate students at our school. Probably like 24, what are they saying? Average time spent studying, like 24 hours a day. All right, she randomly sampled graduate students from our school and obtained a 99% confidence interval of 15 to 25 hours per week. I would say much higher, probably. What is the margin of error? Now, guys, what we just did on number 5, if I do that same method, I'm going to get the wrong answer. If I do 15 plus 25 and divide that by 2, I get 20. Guess what 20 is? 20 is the sample mean. It's the point estimate. So you're not going to call that point estimate the margin of error. Remember, margin of error is what you add or what you subtract to this 20, this sample estimate, to go up to the upper limit and to go down to the lower limit. So what did they have to add to 20 to go up to 25? And what did they have to subtract from 20 to go down to 15? And it's kind of easy to see, right? The number is 5. So the margin of error is going to be 5, but here's a shortcut on how to find the margin of error using the upper limit and the lower limit. And I didn't really write it down because I know You can take notes. So try this for me. Subtract these numbers. Do 25 minus 15 for me. That's the distance between 15 and 25. Divide that by 2. So the distance to the midpoint is going to be exactly 5. So the margin of error is going to be 5 hours per week. So if you want the point estimate, sample mean or sample proportion, given an upper and lower limit, you add them and divide by 2. If you want the margin of error, you do upper limit minus lower limit, and then you divide that by 2. If you submit the quiz, you will get 6 out of 6. I'll know who's actually watching and keeping up, because I know, it's hard to click on a 45-minute video and, but I know you need to, because I need you to learn everything in Math 245, because I know it's remote class, but it's still going on. So please stay with me for the next 3 weeks. This was 8.2, and I will be back with 8.3 lesson video shortly. And after 8.3, why don't we go over some homework problems on my labs, okay? All right, I'll see you very soon.